Hello students, and welcome to our quick revision session with Mr. Mpundu. And in our quick revision session for today, we want to consider one question from the 2018 November edition of Mathematics Paper 1 exam. So I want to look at question 12, as we can see on the screen. Now question 12 had two parts, the either part, and the other part was the or. So we just want to look at the first part, which is the either part, under circular measures. So let's consider the question, read it together, try to understand it together, and then we see how it was supposed to be worked out. So first things first, let's read the question. So the question read, in the diagram below, AOE is a sector of a circle with center O and radius 3.5 centimeters. Angle AOE equals 2 pi divided by 3 radians, and OBCD is a rhombus touching the sector at P and Q. Full stop. So this is a diagram. They told us in the diagram below, and this is our diagram. The two questions that were required to be answered in this exam were: find, part A, it says the perimeter of the shaded region. The perimeter of the shaded region. 6 marks for that. Part B said the area of the shaded region. The area of the shaded region. 4 marks. Okay. So how was this question supposed to be answered in that exam? So let's first understand the question. Let's observe and let's check out what we have been given. So they've given us two things in here. They've given us a sector, and they've also given us a rhombus. They've given us a sector, and they have also given us a rhombus in this question. So before we even do anything, we need to bring to mind the properties of a rhombus. So if you don't know the properties of a rhombus, then it means you'll be stuck. You won't know how to go about answering this question because they've just mentioned to say it's a rhombus. So now, how are we going to work out the question if we don't know the properties of a rhombus? It becomes difficult for everyone. So first things first, understand the properties of a rhombus. Okay. So we are going to highlight those properties of a rhombus in this question as we go together with it to go through it together. But before we go through it together, let's also talk about one thing that every student needs to remember whenever they are answering a question on circular measures. So we've identified the question as a question under circular measures. So what do you need to know about circular measures? Okay. So first things first. If you are using, let me not say if you are using, the calculator you are using should be a scientific calculator. And that calculator you're using, first things first, is that it's supposed to be in radians. Remember the angle that has been given in the question says 2 pi divided by 3 radians. So make sure your calculator is in radians. The default setting for many of the calculators is degrees, but anything to do with circular measures is supposed to be worked out in radians. So make sure you change the mode of your calculator from degrees to radians. Okay, why do we need to do that? So like I've mentioned already, the angle given is in radians, so everything we are doing will be worked out in radians. Now the other reason why we do that is because under circular measures we just have two formulas, just two formulas. That's why it's this topic is quite simple and straightforward, because under circular measures you only have two formulas: the length of an arc and the area of a sector. Those are the two formulas. Now those formulas are given in radians. Those formulas are given in radians, or those formulas given under circular measures can only work when you are using your calculator in radians. And so it's very important to have that skill of quickly changing the mode of the calculator from degrees to radians, from radians to degrees, because in an exam you have questions that will have radians and questions that will have degrees. So that's one thing that you need to know. Okay, having tackled that, let's get back to our question. So we are trying to find the perimeter of the shaded region. So how do we find the perimeter of the shaded region? So let's write This is our solution. Okay. Solution. So part A, we have been told to find the perimeter. We are going to use the letter P to stand for perimeter. Now, what is perimeter? Perimeter is just the total distance around the given shape, or the total distance around the given object. Now, in our case, what is that given shape, or what is that given object? So the question is telling us to say, find the perimeter of the shaded region. Find the perimeter of the shaded region. So when you come to our diagram here, you can see that shaded part, and that shaded part. So that's the shaded region. So what will be the perimeter of this shaded region? Or in other ways, we can say, what is the total distance around this shaded region? Let's check it out. So this shaded region has got several parts. So we can say, let's start from A. So it has got this portion, this straight line, which is AB. Then it has got the other straight line, which is B to C. Or someone can say B to P, P to C. But it's okay if you just say B to C. Then C to D. Or someone can say C to Q, Q to P, or to D, sorry. Then D to E, E to A. This arc, there is this arc. So that's the total distance around that shaded region. So it's from A to B, B to C, C to D, D to E, E all the way back to A, like that. That's our shaded region. So let's write down the formula. So the formula for the perimeter will be the line AB plus the line BC plus the line CD plus the line DE plus the arc EA, or you can say AE. So this is the formula that we are going to use to find the perimeter. What we have written here covers the whole region, or the whole distance or length around the given object. So we move from AB to BC to CD to DE. From DE, you move to arc AE. That gives us the shaded region. Okay, I hope you are together up to this stage. And if we are together up to this stage, then we check out the parts that have been, the parts that we have written in this formula. What are those parts? So there is AB. You go back to the diagram. Do we have AB? That short length there, AB. Do we have it? According to the question, we don't have it. What we have been given is OA. OA. We don't have AB. And because we don't have AB, it means we will need to calculate the length AB. Excuse me. So how are we going to find the length AB? So we notice that AB is part of the side of a rhombus, OB. So we have the side of the rhombus OB, BC, CD, and DO. So these are the four sides of the rhombus. So we know that AB is part of the one side of the rhombus, OB. So if we know what OB is, then we can find our AB simply by subtracting OB minus OA. We will subtract OB minus OA. That is going to give us the length AB. Okay, so for us to find AB, we know that we need to find the length of the rhombus. Okay, before we go, before we move on to calculating the length of the rhombus, let's check other parts of the formula. That's the perimeter. The next thing there is BC. BC. What is BC? BC is the full side of the rhombus. So in us finding our AB, we will have already found our BC. So in calculating AB, we will have found our BC. What is BC? So BC is the side of a rhombus. What is the next thing in the formula? It is CD. CD. So CD, this part, when you go on the diagram, CD is that side. Now, how are we going to find the length of CD? This is where it now brings us to the properties of a rhombus. What are the properties of a rhombus? Because in this rhombus, we need to find our OB, we need to find our BC, we need to find our CD, and also we need to find our DE. So does it mean we have to start calculating each length of this rhombus? Not at all. Because the properties of a rhombus are that all the four sides of a rhombus are equal. All the four sides of a rhombus are equal. So that means BC is the same as CD. So immediately we calculate our BC, it means we have found our CD. And also, when we calculate our AB, it means we will have, because we are saying for us to calculate AB, we first need to find our BC, our CD, or our OB, or our OD. All those four sides of a rhombus are equal. So for us to calculate AB, we need to know first the length of the side, the rhombus. So if we find the length of the rhombus, it will help us to find AB. What else is in the formula? DE. DE. Now DE, if you pay particular attention, it's the same length as AB. Why do we say it's the same length as AB? It's simply because DE is coming from the side OD, and that's the side of the rhombus. Now, from O to E, it's the same distance as O to A because it's a radius. So in short, we are saying, we can even write it down on the diagram, this OE is the same as 3.5 centimeters because it's the same length as OA. So if it's the same length, and we have said the length of a rhombus, all the four sides of a rhombus are equal, it means to find DE, we are still going to subtract OD minus OE. So it will be the same thing as finding AB. So it tells us that this question is very quite straightforward because we just need to find two things, or sorry, not two things, three things. The length of the rhombus, because all the sides are equal. We need to find AB. Immediately we find AB, it means we have found DE also. Then the third thing that we are going to calculate is the length of the arc AE. So that's pretty much the question. That's pretty much the question, or the formula for the perimeter. We have explained it. Now let's go ahead and calculate the length of the rhombus. How do we calculate the length of the rhombus? The question has given us practical information or very cardinal information that is going to help us to calculate the length of the rhombus. That is the side, any of those four sides, because they are equal. So how are we going to do that? Let's go back to the question. It says in the diagram below, OAE is a sector with center O. OAE is a sector with center O and radius 3.5. They've given us the angle here, and they've given us this thing to say it's a rhombus which is touching the sector at P and Q. Now, this information saying it is touching the sector at P and Q, this information which is saying it is touching the sector at P and Q, this part of the question is very important because when a sector touches a line at any point, when a sector touches a line or a line touches a sector, or we can say when a line touches a circle or a curve, what happens is that they form a tangent. So at this point Q, at the point Q, we have a tangent to the sector. And also at the point P, we have a tangent to the sector. Now that information is very, very cardinal. Why is it cardinal? It's because if we come to the diagram and draw a line from Q, there from Q, come down like that, all the way up to the center O. Draw a line. So let me just draw it nicely so that we can see it clearly. So I'm saying if you draw a line from Q coming down all the way to O. Oof, that line is not straight. Let's straighten it. So from Q, come down from Q all the way up to O. That line we have drawn, the broken line we have drawn from O to P. Remember, it's from the center to where? To the circle or to the sector. And it is also from the center to the point Q. So that line is also the radius. Q becomes the radius. Now, whenever you are dealing with questions under circular measures, you can add anything to the diagram for as long as what you are adding is correct, or for as long as what you are adding to the diagram is not a wrong thing. And in this case, this line we have drawn from O to Q, or from Q to O, is not something wrong that we have added to the diagram, because it's a radius. From the center to the circumference of the circle, you get the radius. But this time, from O to that point Q, which is a tangent, that point Q is touching the circle. So that is a radius and also a tangent. And the property that you need to understand is that every time a radius meets a tangent, at that point where there is a tangent, you form a 90 degrees. So that square I've drawn there at Q is showing that the angle DQ and O is a 90 degrees. DQO is a 90 degrees because always a tangent and a radius meet at 90 degrees. That's what happens. So we have that. And from here, we can say we have formed a triangle. We have formed a triangle, a very special triangle. This triangle, DQO. Here there is a 90 degrees. So we have formed a right angled triangle. And from a right angled triangle, we can calculate the sides of a right angled triangle. We have one side which is 3.5. This side DO is 3.5. So we are trying to, not the side D, but OE. OE is 3.5. So the side we are talking about here is not the side OD. Let me just change this. We are saying the length OQ, this length is 3.5. That length is 3.5 centimeters. So since this length is 3.5 centimeters, we can calculate the length of our OD. Now, how are we going to calculate the length of OD? We need an angle in this one, in this triangle. And that angle is this angle here, the angle ODQ. We need to know the angle ODQ. If we know the angle ODQ, then we can calculate the length of OD using Focator. Okay. Now, are we able to find the angle ODQ? Yes, we are able to find this angle. Why? Because when you come to the original diagram here, we have been given this angle, one angle in the rhombus. So it just takes us to have one angle in the rhombus to find the other three angles. Because the properties are that opposite angles in a rhombus opposite angles in a rhombus are equal. So the angle O and the angle C there, they are equal. They are the same. So this angle and this angle, they are equal. Same goes to the angle D, the angle at the point D and the angle at the point B. They are also equal because they are opposite angles. Now, if they are equal, then it means when we add all the four angles in here, they should give us 360. But then we don't need to start going through that process. We can easily find this angle using one simple property that is usually learned in should be grade 9 when we are dealing with parallel lines. So another property of a rhombus. So remember I mentioned from start to say we need to know the properties of a rhombus. That's the only way we are going to answer this question. Without those properties, it will be very difficult for you to answer this question. So another property of a rhombus, apart from the opposite angles being equal and all the four sides being equal, one of the most important properties of a rhombus is that all the opposite sides are parallel. So the side OB and the side DC are parallel. So if the side OB and the side DC are parallel, and then we have this line OD, we have the line OD there. What this tells us is that this OD is it a transversal or transversal? Yes, that should be a transversal. Yeah, according to grade 9 work. Long time I looked at those things, yeah. But this becomes a transversal. And then these two angles, the angle at D and the angle at O, what they are going to form is what we call supplementary angles. They'll form supplementary angles. What are supplementary angles? Supplementary angles are angles that when you add, they give you 180. So when we add the angles, this angle at O, so when we add the angle O plus the angle D, it should give us 180 degrees. That's according to supplementary angles. But remember, this question is in radians, so we are saying O plus D, that's the angle O plus the angle D, is going to give us pi radians, because 180 is the same as pi. Okay, but we know the angle O. The angle O is 2 pi divided by 3. And the way we have written here, O plus D is equals to pi, meaning our D will simply be equal to pi minus O when the O comes to the other side of the equation. This means that our D will be equal to pi radians minus 2 pi divided by 3. And this is just going to give us D, that's the angle D is equals to, when you work out this, so you can multiply 3 by pi, or 3 times pi, minus 2 pi. So 3 times pi is 3 pi, minus 2 pi, you're going to get pi divided by 3. So the angle at D is pi over 3 radians. The angle at D is pi over 3 radians. So others will start asking, how have we found pi over 3? We've just subtracted pi divided by 2 pi over 3. How have we done that? So look at this part here on the top left there. We are saying pi minus 2 pi divided by 3. This pi, any number, is over 1. Find the common denominator, you get 3. 1 into 3 is 3. 3 times pi, you get 3 pi. Minus 3 into 3 is 1. 1 times 2 pi, you get 2 pi. These are like terms. 3 pi minus 2 pi, you're going to get pi divided by 3. That's how we found this pi divided by 3 radians. So we know the angle here in the diagram, this angle is simply pi divided by 3. So we know that angle. And because we know this angle, then we can calculate the length of, that's the length OD. Now, because this is a right angle triangle, it means OD is the hypotenuse. Because this is a right angle triangle, it means OD is the hypotenuse. Now, since OD is the hypotenuse, what does that mean? Since OD, this one we are saying is the hypotenuse, it means since we have this angle, it means this side here will be the opposite. This side becomes the adjacent. So we are getting these things from SOHCAHTOA. So we know SOHCAHTOA, in a right angle triangle, you have the opposite side, the hypotenuse side, and you have the adjacent side. So we are saying this is the hypotenuse, this is the adjacent, and that's the opposite. Okay. So which ratio can we use to calculate the hypotenuse, which is OD? Clearly, based on the angle that we have been given, or the angle we have just calculated, which is pi over 3, it means that for this question, we are going to use the sine ratio. So we are going to say sine of the angle D, or the angle at D, should be equal to the opposite over the hypotenuse. That's how we use the sine. Because we have the opposite side. Let's substitute, or let's make h the subject. When you do your cross multiplication here, it's going to give you your h, which is the hypotenuse, as opposite divided by sine of the angle D. That's how we are going to find our h. H will be equal to opposite divided by sine of D. So that's making the subject. Cross multiply h times sine D is equals to O, divide both sides by sine D. You're going to end up with h is equals to opposite over sine D. Let's come to the next page here, and then we see how we are going to find h. So our h, so let's come back to that. So we are saying our h, sorry, okay. Oof, I've lost the page. Let me just get back the page. Okay, I've gotten back the page. So I was saying our h. Oof, what's happening? Let's get back to our question. So we are saying our h will be equal to, our opposite is 3.5 divided by our sine of pi divided by 3. Sine of pi divided by 3. This will be equal to, when you go on the calculator and type in those figures, you're going to find that the hypotenuse is simply going to be punch in 3.5 divided by sine of pi divided by 3. When you round it off, you're going to get 4.04 centimeters. 4.04 centimeters. Now this hypotenuse is the same as the side of the side OD, the side OD, and OD is one of the sides of the rhombus. So what we have done here, we have just calculated one of the sides of the rhombus, and it means we have pretty much done much of the work in this question, because we can now calculate our AB. AB will be equal to OB minus OA, or DE is the same as OD minus OE. But let's go with AE because we said these are equal. So this will be equal to 4, our OB is 4.04 minus our OA is 3.5. When you subtract those two, you're going to get AB, which is equal to DE. It will be equal to, so let's subtract those two, you're going to get 0.54 when you round off to 2 decimal places, 0.54 centimeters. That becomes our our AB, which is the same as AD. So pretty much we have worked out majority of the things we need to calculate the perimeter. The next thing is just that we need to find, because when we get back to this formula, we'll find that we have found AB, we have found BC, we have found CD, we have found DE. All we are remaining with is the length of the arc AE. The length of the arc AE. The question is, how do we find the length of the arc AE? Let's get back to the formulas. Length of an arc. Length of an arc, they usually use the letter S to represent length of an arc, and is given by theta r. Length of an arc is given by theta r. So we are looking for the length of the arc what? So that S will be the length of the arc AE, which will be equal to our theta in this case. So AE will be equal to, let me write that properly. Yeah, AE is equal to our theta. According to the question, the angle for this sector we are looking for is at the angle O, and the angle O is 2 pi divided by 3 radians. So our length of that arc is going to be equal to 2 pi divided by 3 multiplied by the radius. What is the radius of the sector? 3.5 centimeters. When you carry out that multiplication, it's going to give you the length of the arc as, so when you go on the calculator, you type in those figures, 2 pi divided by 3 multiplied by 3.5, it is going to give you 7.33 centimeters. So this is the length of the arc, the arc AE. So we have found the length of the arc AE. What do we do next? Let's find the perimeter. Perimeter will be equal to AB. Remember what we said, the formula we can see there, we can see it on the screen. It's AB. What is our AB? Our AB we have found is 0.54 plus our BC. What is our BC? Our BC is the length of the rhombus, is 4.04 plus our CD. What's our CD? Still the length of the rhombus, 4.04 plus DE. What's our DE? DE is the same as AE, that is 0.54 centimeters plus the next thing, or the last thing, length of the arc. What is the length of the arc? We have just calculated 7.33. Those are the things that we need for the perimeter, and therefore the perimeter will simply be equal to, add, get your calculator and start typing in 0.54 plus 4.04 plus 4.04 plus 0.54 plus 7.33. When you work out that and you round off to 3 significant figures, you are going to get your final solution as 16.5 centimeters. 16.5 centimeters. This gives us the perimeter of the shaded region. The perimeter of the shaded region. Remember, we were required to find the perimeter, and we wrote the formula for the perimeter, and we have checked out all the things that we needed for that formula. We have calculated all those things. Go on and do your calculations. You arrive at 16.5 centimeters as the perimeter for that question. So that gives you 6 marks, because they are telling us to say the perimeter of the shaded region carries 6 marks. Okay, let's go to part B. So what are we supposed to do in part B? So part B, sorry, I lost that again. Let me get back to my page. Let me get back to my page. Okay, so we are saying the area. This time we are required to find the area. Okay, how do we get the area? So part B, let's write down B. Area. We're going to use the capital letter A to represent area. Now it's area of what? It's area of the shaded region. What is the shaded region? We already identified the shaded region. So the shaded region is inside the rhombus. But then inside the rhombus there's a sector, and that's the unshaded part. So the area of the shaded part will be, it will be the area, we are going to call it area 1, that is area of the whole rhombus. Area 1 of the whole rhombus, minus what is not shaded inside that rhombus is the sector. So we are going to say area 2 minus area 2. What is that area 2? Area 2 is the area of the sector. So to find the area of the shaded region, we will need to subtract the area of the rhombus minus the area of the sector. That is that portion of the rhombus which is not shaded, and that's the area of the sector. So let's go ahead and find area 1. And then we are going to find area 2. After doing that, we are going to calculate the area of the shaded region. So the question is, how do we calculate area 1? There is a formula that you use to calculate the area of the rhombus, which is area 1. But I don't want to use that formula. I want to use what is familiar to us. So let's get back to our diagram. So when we go back to our diagram here, let's draw a line OC. The line OC. That line OC which I have drawn there divides the rhombus into 2 equal triangles. The line OC divides, so let me draw the line OC properly so that we can clearly see what we have. Okay, let's draw the line OC properly, or better. Okay, that is the line OC. So the line OC divides the rhombus into 2 equal triangles. So if we calculate the triangle, one of the triangles, it means we calculate the other triangle. So it means we just multiply by 2. The area of one triangle times 2, then it gives us the area of the whole rhombus. So we are saying the area of the whole rhombus will be equal to, the area of the whole rhombus will be equal to 2 times the area of the triangle. Area of the triangle. That's what we are going to have, because we have 2 triangles. Now, what is the area of the triangle? So this will be 2 multiplied by the area of the triangle. What formula are we going to use? We have 2 formulas. The formula when you have a right angle triangle, and the formula when you have a non-right angle triangle. So when you look at the 2 triangles we have, ODC, ODC. So ODC is not a right angle triangle, meaning we can't use the formula for the right angle triangle, which is half base times height. It means we are going to use the formula AB sine C, half AB sine C. Now in this case, we are going to have the formula half OQ sine D. Half OQ sine D. Someone will ask, why half OQ sine D? So in a triangle, according to trigonometry, in this triangle ODC, the triangle ODC. So look at the triangle ODC. So the triangle ODC has got three sides. So the side opposite to O, this side which is this side, the side DC, will be represented by the length O. Then the side OD will be represented by C. Oh, sorry, not C. Yeah. Oh, sorry. Yeah, that's C. C. So the formula actually is supposed to be OC, half OC sine D, half OC sine D. I wrote Q here. Where there is Q, we are supposed to have C. Half OC sine D. Let's work it out. This will be equal to 2 multiplied by half times our O is what we have calculated. That is the length of the rhombus, which is 4.04. 4.04. Now, since OC and O are equal, we are going to have 4.04 squared. Then times the sine of the angle. The angle D is pi divided by 3, like that. So when you work this out, 2 times half times 4.04 squared times sine 3 pi. This is going to give us the answer 14.1, rounded off. 14.1 square centimeters. 14.1 square centimeters. That's the area of the whole rhombus. Let's work out area 2. Area 2 is the area of a sector. Area 2 is the area of a sector. So let's work out the area of a sector. Area of a sector is given by theta r squared divided by 2. So we already know what our theta is. We already know what our radius is. Then we are just going to divide that by 2. So this is going to give us, so our theta times r squared. So theta is 2 pi divided by 3 multiplied by our radius is 3.5 squared. So what we have written in brackets there is the numerator. The angle, that is for the sector, 2 pi divided by 3 times 3.5 squared, then divided by 2. That's according to the formula. When you work out this, you are going to get 12.8 centimeters or square centimeters. This is what you are going to have. When you type in that on the calculator, work it out, you round off, you are going to get 12.8 square centimeters. And therefore, we can calculate the area of the shaded region. Because we have said area of the shaded region is given by A is equals to A1. Our A1 is 14.1 minus A2, 12.8. When you subtract those two figures, they are going to give you 1.3 square centimeters. So when you subtract 14.1 divided by 12.8, you get 1.3 square centimeters. I've written cubic centimeters there. It's not supposed to be cubic centimeters. It's supposed to be square centimeters. That's what we are going to write there. And this is going to give you the 4 marks that you needed for this question. So with this, we have answered the 2 questions. So you get your 4 marks for the area and you get your 6 marks for the perimeter. So I've taken a lot of time working out this question because I was trying to explain to make you understand. On your own, you're not supposed to spend more than 20 minutes on this question. 15 minutes should be enough for you to work out this question. If you're on your own with your calculator, with your everything that you need, it shouldn't take you more than this time that we've done it in. So this was just us revising this question, see how you are supposed to work it out, and this is how it was supposed to be worked out. I hope you understand or you followed through my explanation. Sometimes I can be too fast, but I hope you followed. So we end here with our quick revision session for today, and thank you for joining. Please remember to follow my Facebook page and also subscribe to my YouTube channel so that every time I post a video, interesting videos like this one, you're going to be notified, and then you're going to benefit also. And also others, help others also to benefit. Share with your friends who are taking additional mathematics, and see how we can deal with circular measures. It's one topic that gives PPU's challenges, but yeah, we can see how we can simplify it. Let's look forward to our next question in our quick revision sessions. For today, we end here, and bye-bye. See you next time.